talking about exponential functions. And this is what we've had. We have had functions where the base is the variable and the exponent is a constant. And we've done, linear, we've done quadratic, we've done cubic, where that we've had a variable here and our exponent is a constant. And now we're going to switch it up. We're going to do actually just the opposite, where we are going to have our base is going to be a constant and our exponent is the variable. Okay? So you just need to make sure you understand what's happening here. We're switching things up. Okay? No.
That's a 2bx.
That's 2bx. That's an x, sorry. All right. So I'm going to give you a definition, and we'll talk about the definition in a few minutes. I just want you to know that we have y equals ab to the x. That's the form that exponential functions have, and it's a definition. Okay, what is a mammal, or what makes something an amphibian? There are certain things that make it, and you define what it is, and that's what we are going to do with exponential functions. Where y equals ab to the x, where a, b, and x are real numbers. Okay, and that's just by definition, and we'll look at it in a few minutes why that is. B has to be greater than 0. B does not equal 1. And the base is constant. Okay, so it's a number. Now, sorry to have to give you notes like this, but you haven't. We can refer to it, and we'll be talking about, there's a lot of language involved in this.
Do we use E in this?
I'm sorry, are we using what?
E.
E, yes, we will be using E. Okay? So, and we can use irrational numbers. Irrational numbers are real numbers, right? And we will just round. For instance, if we had b to pi, or we're going to use e, b to a number to the e. It sounds like some of you are familiar with e. So we can use irrational numbers. Remember, they're real numbers. And we would just round it to b to 3.14. Okay? So far, so good? All right. So let's graph. So take out your graph, and let's just look at what that looks like. Pardon me? Yeah. You want, yes. This is heavy duty notes. Let me see, how much notes do I have? Just a little bit more. Okay, and then we're going to do some problems. Okay, so I would like you to graph those.
All at once?
We can do one at a time. Let's just get an idea of what they are. So we're going to use at this time 2, and we're raising that to the x. And if I graph that, okay, so let's look at, I'm going to get rid of my negative y scale, and I'm just going to have y in maybe a -1. And let's see what happens. And what else do I want to do? Let's look at the table. Let's just see. So second table. And I have everybody there, second table. So I'm in my negative numbers. What's happening? My negative numbers are getting smaller. what does this mean, 3.1 e to the negative 5?
Exponent.
Okay, so and remember, this is an exponent, it's a negative exponent. Is this number pretty small?
Yeah.
Okay, so one of the characteristics of an exponential function is that there, what do you think exists there? Am I going to hit 0? No. So what do I call something that gets very, very close but doesn't touch?
No. It was that word.
We used it when x could not equal 0 in the denominator.
Undefined.
It would be undefined. We're not saying it's undefined here. We're saying we have an asymptote there. But our asymptote is horizontal, okay? The other ones have been when x was a value. So we're looking here, and an exponential function will not hit that 0, okay?
So all exponential functions will not hit.
That's right. So let's graph, so that's what, let's go back to your notes, and I'd like you to have a little sketch, and it is, we know that it's going to look, it's going to go up, and then we're going to do another one. I'm going to give you more, we'll have, I just am trying to give you an idea of what they, how they behave.
Exponential functions will not hit what?
Zeros.
Will not cross the x-axis. It will cross the y-axis, okay, but it won't hit 0. When x is, when y is 0, I should say. Okay, so let's see what happens when you have, let's go back and graph y equals, and we'll have a base of 5. And what happens here? Shorter or
Steeper.
Steeper. Yeah, okay. So you know that they're going to get steeper. And then let's just, for the fun of it, now that we're here, just do y equals 10x. Actually, let's, I take that back. Well, 10x, all right, we're good. Oh, I'm sorry, I didn't grab that right. Y equals 10x. It's going to be pretty steep, right?
Straight up and down.
Yeah, barely, it's right in there. Okay, so let's go back to y equals. I'm going to clear these guys. In our definition, we had said that b was going to be greater than 0. Can I have 1/3? 1 divided by 3, is that greater than 0? Okay, so let's see what happens if it's less than 1. 1/3 is less than 1.
So you have to have parentheses. It's 1 divided by 3 raised to the x.
All right. Yeah, those parentheses. Laura and I just did a problem, and it's all about those parentheses. I forgot. Thank you, Steve. Okay, and if I graph that, it goes the other way. Okay.
Remember, it's less than 1 it'll go the other way.
It goes the other way. When it's less than 1, it's going to go the other way. So why don't you add that to your sketches? So we had 2 raised to the x, 5, 10, and then, oh, actually right here. Okay, so our notes should comment. So let me see if I can zoom in. Can you see that? All right, so our graph is when we have 2 to the x, we have a sketch. It doesn't touch, it doesn't cross the x-axis. We have it's getting steeper. It's going to get steeper, and it's rising from left to right when b is greater than 1. Okay? And then when b is less than 1, but it's going to be greater than 0, we can see that the graph falls from left to right. Okay? So, both of them always contain, what number? No?
1.
All of them all contain 1 to the b, whatever that b value is, because, let's see if you can think about that, because what?
All of what always contains?
They both of them contain, if I have one that is greater than 1 or less than 1 but greater than
Okay.
0, okay? They're all going to contain the number 1 and the number, because what happens when I have let's say I have 2 to the first.
It's 2.
It's going to be 2. This is the thing that you need to remember. What does this represent? An X or a Y? Isn't that my X? So when my X is 1, my B is what? My Y value is
I don't understand.
whatever the number is. I will always have those points. So if I had,
Why do we always have 1?
well, how about if I